Another factor that determines the way a disease is expressed has to do with whether the functions that it is affecting are fixed or adjustable. And whether a function is fixed or adjustable depends on its sensitivity to the environment. Some developmental and physiological processes are very sensitive to environmental change. That would include glucose metabolism and blood pressure. Others are rather insensitive. For example, DNA replication and purine metabolism are not very sensitive to the environment. Sensitive reactions evolve to be adjustable, and insensitive reactions evolve to be fixed. So adjustable reactions are buying flexibility at the cost of vulnerability to dysregulation, insulin resistance and type 2 diabetes, for example. Insensitive reactions are robust to dysregulation, but they remain vulnerable to genetic defects. So they are more likely to undergo catastrophic failure, whereas adjustable reactions are likely to undergo a sort of progressive failure. Let's unpack them. Fixed functions are insensitive to the environment, highly conserved, control core biological processes, and are disrupted by single catastrophic mutations. They are responsible for rare Mendelian diseases such as cystic fibrosis or progeria. Adjustable functions are sensitive to the environment. They vary within and between species. They're constantly shaped by natural selection. They're directly involved in local adaptation. They control physiological adaptation, inducible responses, and reaction norms. They are affected by many genes, often polymorphic, whose frequencies change under selection. They cause predisposition to diseases of mismatch, such as obesity, type 2 diabetes, asthma, hypertension, and so forth. So a few comments on fixed processes. These are some of the examples of catastrophic failure due to mutations. Core biological processes are fixed. They include DNA replication, transcription of actin for the cytoskeleton, and so forth. Major features of the body plan are fixed by developmental control. That's the number of heads, legs, arms, digits, and eyes. And these are all mutations affecting heads, digits, and eyes. Mutations disrupting such traits can have catastrophic effects, which you see here. They are often caught by quality control of gametes, of zygotes, and concepti. When they're not caught, they result in major birth defects. Adjustable features vary on the different time scales that we have already visited. So physiological adaptation is occurring in fractions of a lifespan. Acclimation up to about a lifespan, and developmental plasticity at about a lifespan. Developmental plasticity is often irreversible. Acclimation is often achieved through rheostasis, that is, changes in the set point of the homeostatic feedbacks. And physiological adaptation is usually regulated through a homeostatic feedback loop. An example of an adjustable process is glucose distribution in the body. It is controlled by insulin. Its set points change during pregnancy to privilege the fetus so that the fat and the skeletal muscle of the mother becomes more insulin resistant to maintain a higher glucose level in the blood that can then be taken up by the developing fetus. And during infection, the same kind of switch will occur to privilege the immune system. So the skeletal muscle and the fat cells become insulin resistant to keep the glucose level elevated in the blood so it can be used by the immune system. This kind of adjustability comes with a price. The diseases of homeostasis, which include insulin resistance and type 2 diabetes. The symptoms of type 2 diabetes are excess thirst, frequent urination, constant hunger, and the long-term complications of heart disease, strokes, kidney failure, and amputations. So it was very adaptive for evolution to design an adjustable process to regulate glucose distribution in the body, both to aid in pregnancy and to aid in disease defense, but it created a vulnerability that allowed a type of disease to arise that can be very debilitating, particularly in older people. To summarize, fixed traits are insensitive to the environment, they're deeply conserved, they're often developmentally canalized. Mutations that disrupt such traits act early in development, and they can often have catastrophic consequences. Adjustable traits react sensitively to changes in the environment. They are often controlled by many genes that have allelic variation. The disruption of an adjustable trait, whether it's by genetic mutations or by environmental insults, produces diseases of homeostasis, such as diabetes, type 2 diabetes.